Welcome to our review on walls and insulation. First thing we need to think about is what's happening inside our houses when it's cold. So when it gets cold, we turn on the central heating in order to keep the houses warm. And when we turn that heating off, then the house will cool down as energy is transferred to the surroundings via the walls, the windows, etc. So what we actually find is that when we're considering why houses don't all cool down at the same rate, then it's going to depend on three key differences. Firstly, the thickness of the walls. Secondly, the material the walls are made of. And lastly, the temperature difference between the inside and the outside of the wall. If we consider the thickness of the wall first of all, then what we've got in the diagram at the top there are two walls, so made of the same material, and you can see the temperature difference is the same, as we've got 2 degrees outside, 22 degrees inside. So the only difference is the thickness of the wall itself. And when you look at the graph just beneath, you can see that the thicker wall is the one that's going to keep the warmer temperatures inside for longer. So it's got a lower rate of cooling than the thin wall. So it's more beneficial to have a thicker wall than a thinner wall. What we tend to find in UK houses is that if you're in a more modern house, then there are two layers of brick or stone with insulation between them, and this is known as a cavity wall. If you're in an older house, particularly those of the Victorian Edwardian era or before, then it's likely to be a solid brick wall. So rather than having the cavity, it's, as the name suggests, just bricks that are solid as the entire wall. So if you've got a cavity wall, then quite often what you should be doing, if you haven't already got it, is getting cavity wall insulation. Because what we find is different materials have different thermal conductivities. And the thermal conductivity of a material tells you the rate at which it's going to transfer energy through a wall, with an area of 1 meter squared, a thickness of 1 meter, and a temperature difference of 1 degree Celsius. So it gives you a number that you can then compare for all the different materials to identify which is best. So what you could be given is a table like this, where we've got a variety of different materials that could be used and their relative thermal conductivities on the right there. So what we can see straight away is that when we're considering the relative thermal conductivity, the lower the number, the better. Because remember, it's the rate at which it transfers energy, so you want the smallest number possible. So brick, for example, has a thermal conductivity of 1.31, which is the highest on our list there. So just having brick, so those solid brick houses, the older ones, are pretty rubbish at keeping the heat inside your house, which is why they tend to be a little bit more expensive to heat. So when we're considering what could we do about this, then if you've got an older house, the answer is not a huge amount unless you want to put a load of cladding on the outside. Because what you used to have to do is use something like the foam insulation you can see in the top right there in order to try to insulate. But that then means you have to put the cladding on the outside and so on, or lose a sizable chunk of your room inside. Not preferable. So instead, there's now a new option, which is a stuff called aerogel, which you can see in the bottom right corner there. So that is literally a thin sheet of aerogel which someone is holding above a Bunsen burner flame with a hand on it with no issues. So aerogel is actually the stuff they've used on the space shuttle as insulation. So you get these amazing insulating properties with only a very thin piece of the material. So my suggestion would be, if you've got an old property and you need to insulate it, then aerogel would be your best bet. It will cost you a little bit more in the first place, but it will make the biggest difference. For those of you with cavity walls, then obviously the foam wall insulation is very good with 0.03. And in your roof, if you haven't got that insulation in your loft space, then that will make a big difference as well. As you can see, its relative thermal conductivity 0.04. But when you're given a table like that, just make sure that you can select the one with the lowest number, because that means it's going to take longer to transfer the heat from inside to outside. So just to consider how this looks in terms of our graph with temperature over time, then if we've got the same temperature difference, the same thickness, but all we've changed is the thermal conductivity, you can see that the wall with the low thermal conductivity retains higher temperatures for longer and therefore is better. Hopefully at the end of this video you can describe how the rate of cooling depends on the thickness of the walls, and you can describe how the rate of cooling depends on the thermal conductivity of walls, suggesting which material would be best to use for insulation from a table of information.